Hey, I'm Hunter, and I'm giving my presentation on Wolbachia mosquitoes. So let's get into it. What is Wolbachia? The bacteria of the genus Wolbachia are bacteria that live within the cells of their hosts. They infect a wide range of arthropods. Arthropods are insects, arachnids, and crustaceans, and some nematodes, which are parasitic roundworms. Scientists estimate that Wolbachia exists between 17 and 65% of all arthropods and nematodes, and it is safe to humans. The decision needed to be made is that should me and my team release Wolbachia-infected mosquitoes on the island of Kauai, Hawaii, to help save native birds from the side effects of avian pox and avian malaria, as well as regress the transmission of dengue virus to humans from mosquitoes. And there's some good images. This is how we'd release them, just like in that fashion there. How does it work? When mosquitoes carry the natural Wolbachia bacteria, the transmission of viruses like dengue, Zika, chikungunya, and yellow fever is reduced. The bacteria compete with the viruses and make it harder for the mosquitoes to transmit disease from person to person. This is a natural and non-harmful solution to control mosquito-borne diseases. Where has this been tested? So Wolbachia-treated mosquitoes were released every 2 weeks in the city of Yogyakarta City, Indonesia. So just in one half. And then the other half of the city did not get the Wolbachia mosquitoes released and was treated as the control in the experiment. So half of the city got them, half of them don't. And then this lasted for 13 to 15 rounds of releases. And the data of new cases of dengue fever was kept to measure the impact of the released mosquitoes and to see if it had an effect on the dengue cases transmitted. So basically every time somebody got dengue, they would keep note of it. And the results were there was 34 dengue cases in the intervention area, which is like where they released the mosquitoes, and then compared to 53 from the control area. So pretty much 20 less cases, which is significant. And then, so yeah, there was reduction of dengue fever cases by a regression of 73% due to the release of Wolbachia mosquitoes. And then these findings conclude that there's a significant reduction in dengue fever transmission when Wolbachia mosquitoes are implemented into an environment. And then these had similar results. There was a trial done like this in Northern Australia, and they had similar results of dengue fever regression due to the release of the mosquitoes. And so that further supports our hypothesis that Wolbachia-treated mosquitoes help with the control of dengue fever transmission. Sterile insect techniques. So Wolbachia is a type of sterile insect technique to help control insect populations, basically. So we release sterilized male insects into the environment, and then the female insects are overwhelmed by the influx of all these sterile male insects, and they have trouble with reproduction. So they go to hook up with one of the insects to reproduce, realize one of them, they don't realize they're sterile, and it's just tough for them. And then when a male mosquito carrying Wolbachia mates with a female without Wolbachia, the female's offspring won't hatch and the reproduction fails. So that's how it works. And it lowers the populations of the targeted insect. You can do this for different insects, but really mosquitoes are the problem. So that's why we do it with mosquitoes. What is dengue fever? So dengue fever is a mosquito-borne tropical disease caused by the dengue virus. Symptoms begin 3 to 14 days after infection. They include a high fever, headache, vomiting, muscle and joint pains, and a skin rash that is really noticeable. And the recovery takes 2 to 7 days. And it's not typically fatal, but it's no good. And the mosquitoes don't only impact people, but they impact the Hawaii native birds. So the Hawaii native birds are being bitten by these mosquitoes, and when they bite, infected mosquitoes transmit the avian pox virus or the parasite that causes avian malaria. So they're bitten not like on the feathers, but like on their eyes, around the beak there's exposed skin, and their legs is exposed. So anywhere there's really exposed skin, they'll bite you. And the consequences for these birds is it's bad, it's unattractive, it's often deadly. So A bird infected with the pox gets the large tumors on its legs, eyes, and around its bill. And here there's a, this slide's out of place, but yeah, this is an example of what's happening with the avian pox. Is, look at that. I mean, look at that. That's the cute little birdie's just got these gnarly ass tumors. It's no good. And so these are the birds that are being impacted. It's these native honey creepers, such as the Ikekeke, and the iwi bird are the biggest at risk. So there's the iwi. I think that one's really cute. I like the Ikekeke. These iwi birds are typically only found in high elevation forests of the park. Fuck. Right. That's not how I wanted to put it, but yeah. So they're typically found in high elevation forests, 4,500 feet, where the mosquitoes that transmit avian malaria and avian pox are less common. National Park Service gave me that quote there. So yeah, only 17 of the species of native forest honey creepers remain, down from 39. And then the native birds are being pushed out of their original ecosystem and forced to reside on higher elevated areas. This is due to loss of habitat at lower elevations and the invasion of non-native species into the low mid-elevation habitats, and the distribution of the diseases from these mosquitoes that are just doing them dirty. So birds go to these higher elevations because the mosquitoes are more sensitive to the colder temperatures, and the development of the avian malarial parasites really slow down at temperatures below 17 degrees Celsius and are largely inhibited where the mean annual temperatures are below 15 degrees Celsius. So to get to these lower temperatures, these birds are being pushed out of their native ecosystems and having to go up higher in the forest, which brings problems. So I think that the release of the Wolbachia infected mosquitoes would help the endangered bird. I think that the release of the Wolbachia infected mosquitoes would help endangered birds return to their lower elevation habitats, because it would lower the population of mosquitoes carrying avian pox and avian malaria, which would basically remove the threat and the barrier that keeps them up in this high elevated forest at colder temperatures. And if they could go back to these lower habitats, I think it could help grow the species populations out of their endangered status. Not only it would help grow species populations out of their endangered status, but like the effects the mosquitoes had in northern Australia and Indonesia, the Wolbachia infected mosquitoes would help the regression of the transmission of dengue fever among the humans on the island of Kauai. So I think me and my team should release Wolbachia mosquitoes. Help the birds, help the people. I mean, and it's safe. It doesn't really pose any risk to humans. It doesn't mess with their environment. It doesn't. I think it's a good call. And here are my references. Yeah, I hope you enjoyed my presentation. Thank you so much.